Algorithmia is a marketplace for algorithms. A software engineer who writes an algorithm for image processing or spam detection or TF-IDF can turn that algorithm into a RESTful API to be consumed by other developers. Different algorithms can be composed together to build even higher level algorithms. Diego Oppenheimer is the CEO of Algorithmia, and he joins the show today to explain how Algorithmia works. The company has developed its own container orchestration and management service, and it operates similarly to the serverless computing paradigms that we have discussed on recent episodes of Software Engineering Daily. Diego also talks about the marketplace dynamics of building a platform for developers to sell algorithms to each other. Before we get to today's show, I want to quickly mention that Software Engineering Daily is looking for sponsors. There are around 10,000 11,000 on some days, 12,000 engineers listening. So if you're interested in reaching that audience, you can send me an email at softwareengineeringdaily@gmail.com. And if you're a listener of the show and you want to support Software Engineering Daily, don't worry about donating money through Patreon or something. I just want you to share your favorite episode on Twitter or Facebook. Tell your friends about the show at lunch. I have considered the Patreon model for support, but I think that the advertising model is a more sustainable model. I think it contributes to potential growth opportunities more. So I don't know. If you have any ideas around that, if you think Patreon is a better model, send me an email. I'd be happy to hear your thoughts. But I do sincerely believe that other people would listen to the show if they knew about it, so please share it. And with that said, let's get to this episode. It's a very fascinating episode, Algorithmia with Diego Oppenheimer. Software engineers never stop learning. If you are listening to Software Engineering Daily right now, you enjoy learning so much that you listen to a podcast about technical software topics. IT Pro TV has videos for people like us, people who never stop learning. I'm using IT Pro TV right now to learn about Amazon Web Services, and I found 10 hours of high-quality videos about EC2, elastic load balancers, orchestration, cost management. If I ever decide to start my own tech company, I will need to know how to manage the cost of my servers. Go to itpro.tv/sedaily to get started with a free 7-day trial of videos. You can then use the promo code SEDaily and get a 30% discount, and that discount is permanent. Watching these videos, I have learned how to configure auto-scaling groups together with load balancers. I've learned how to configure a database that can scale up without inconsistencies. If I wanted to test out of the Amazon SysOps certification right now, I could. There are also courses about Microsoft operating systems and networking, VMware virtualization, Cisco routing. You can watch 70 hours about Cisco routing and switching, and it is engaging and entertaining material. If you listen to Software Engineering Daily all the time, this is the kind of material that you will love. You can put it on in the background, and you will find yourself just absorbing the information without even realizing it. You can try it free for 7 days. Go to itpro.tv/sedaily. Use the promo code SEDaily to get 30% off, and after you try it free for 7 days, I have no doubt that you will want to continue to invest in yourself and your future. Thanks to IT Pro TV for sponsoring Software Engineering Daily and for producing this top quality content. Diego Oppenheimer is the CEO of Algorithmia. Diego, welcome to Software Engineering Daily.
Thank you for having me. I'm excited to be here.
Algorithmia is a marketplace for algorithms. Describe how Algorithmia works.
Sure. So what we do is we run essentially algorithms as a service. We're a platform where any developer in the world can come in the language of their choice, come to our site. They can publish their algorithm using either our online IDE or Git pushing to us. As soon as you hit publish, we compile it, send it out to our compute cluster, turn it into a REST API, and now it becomes available through, to be called by REST by any client on Earth.
What are some examples of algorithms that are on the marketplace?
Sure. So we have over 2,000 algorithms today, but they really go a wide range, everything from web scrapers to video splitters to machine learning models to natural language processing. We really have a wide variety of algorithms for a lot of different use cases.
What are the most popular ones?
Definitely image, like computer vision and natural language processing. These have been really the most popular ones, mostly because they're very easy. Inputs and outputs are very easy to understand, even though the complexity of the algorithm is not easy for everybody to understand. But you know that if you're going to put an image in and you're going to get a tag out, like that's a pretty simple thing to understand. And people are really excited when they can play with these kind of advanced computer vision, natural language processing algorithms.
So some developers on Algorithmia are writing algorithms, and other developers are consuming them and building new algorithms out of the pre-existing ones. Describe the workflow and the motivations of the developers on either side of this marketplace, the developers that are writing the algorithms and the ones that are consuming it.
Sure. So, on the supply side, right, or the algorithm developers, it's really about getting your work out there in the easiest, most consumable form possible. Think of it as, you have an option of saying, oh, well, I have this algorithm and I would maybe open source it and put it on GitHub. But, adoption of that really requires somebody downloading it, getting all the dependencies working, setting up a service for it. Like there's a lot of steps, which kind of doesn't make it as easy to adopt. If you use Algorithmia now, you can kind of put, you put it into our system, you publish it. We take care of all the operationalization of these algorithms. And now you have a scalable running service that's going to be available for anybody to be able to use it. On top of that, if you're motivated by, actually making money off of these algorithms, then you have a possibility of also charging, making it available in the marketplace. And the same way that an app developer would post something to think about the iTunes Store or the Google Play Store, they can do the exact same thing with advanced machine learning models or their algorithms inside Algorithmia. So that's kind of from the algorithm developer side. From the consumption side, and I think you had a talk last week about kind of like serverless computing and kind of a lot of the advantages around that. So think about this as an approach to working with advanced, interesting algorithms in that kind of exact same framework. I now have access to potentially thousands of different algorithms that might not be in my area of expertise, where I can now just call an API and use this, and I don't have to worry about setting up servers, EC2 machines, scaling, really. Today my app is hitting an algorithm and I have 5,000 users. Tomorrow I have 5 million. Like, what do you do at that point? Like, that's a really hard process of scaling. Like, we take care of all of that for you. So the motivation is not only to find interesting algorithms that you might not be in your wheelhouse or your understanding, but also that we take care of kind of the operations part of dealing with these.
Yeah, and you mentioned the serverless computing aspect. I definitely want to get into that later because I think that has a lot of applications to this conversation. But talking a little bit more about the fundamentals of Algorithmia, let's say I'm a developer. I want to put an algorithm on Algorithmia. What is the spec that I need to follow? Do I need to create a really well-documented API, or what exactly do I need to do?
Sure. So we've essentially standardized across all the languages that we support, something that we our apply function. And what really that means is inside this apply function, you define what the inputs and outputs of these algorithms are. Because our system, what it can do is it can just read off of that apply function and make sure that that our system can actually automatically generate the API for you. So realistically, what you as an algorithm developer, the only thing you really need to do is really define well this apply function in terms of these are the inputs that it needs, this is the type of output it's going to generate, and then you define the rest of your code inside these algorithms or multiple files there. In terms of documentation, we provide essentially what we call the independent marketing page for every single algorithm, where you can write out the documentation, credit whoever, if it was work from a bunch of different people, you can credit their work there. You can describe how it's used. You can describe the use cases of what it was used for. And then finally, the last part, which is doing permissioning things like, oh, this algorithm requires access to the internet, because this is something that we expose to users for security purposes. So if you say, oh, my algorithm doesn't have access to the internet, then we actually lock down the containers at the time of building that algorithm so that they won't have access to the internet. And this is just kind of a security feature of really allowing people to work with all the algorithms in Algorithmia in a confident fashion.
So let's say I want to use Algorithmia to get better indexing and categorization of my podcast episodes. So I kind of want to go through like an example of how, anybody could use Algorithmia. So I have all of these audio files of podcast episodes, all these episodes I've done. And let's say I want to use some algorithms from Algorithmia to send the audio files through a labeling process. I want to get, I want all of the audio to be indexed and labeled, and I want to understand which episodes mention Apache Spark or React.js or Docker containers. How could I use the algorithms on Algorithmia to build that sort of framework when all I have today is just these raw MP3 files?
Absolutely. This is actually an example of that we built off of YouTube, doing something very similar, except it was for tutorials instead of podcasts. And so the idea here is, you nailed it. Like, so you have all these files, and what you're really curious about is what's being said in them, and like how you can actually categorize and process them. So the first thing that you would do is you would run all the different MP3 or WAV files or whatever format you have through a speech-to-text algorithm. And there's a couple of different ones that we already have from different universities, and they work depending on they're slightly dependent on the corpus of data that you have. So, if it's a newspaper, it's going to have certain language, and it really comes down to like what the training for those algorithms was. So the first thing is use a speech-to-text algorithm. So now you're going to have a long-form text of every single one of your podcasts. So this is where the part gets really interesting. Now you can start applying different natural language processing methodologies and algorithms to those texts to start being able to generate the labeling and the categorization process. So for example, we have an algorithm called LDA, which in a lot of cases which is, it's considered to be kind of a topic extractor. It statistically looks at all the words mentioned in this text, and it tries to pick out what might be the actual topic of the text. And so this will automatically generate some labels for each one of your podcasts. And that might come up and might bring up computing, it might bring up cloud, it might bring up, as you said, Apache Spark. So it'll start picking up of these just because of how often it's mentioned and like the frequency it's used. So this is like one of like the first pass that you would do. You would use an algorithm like LDA to be able to extract these things. Then there's other NLP algorithms like maybe TF-IDF, which is a frequency algorithm, which says if I gave you a set of documents, like a large set of documents, and we analyzed all of them in the context of each other, maybe because you're a software engineering podcast, like the word computing and cloud computing is going to come out a lot. So that's not really a topic, right, of your podcast. Like that's kind of like an overarching theme of a lot of your podcasts. So it would deprioritize those, and it would reprioritize other labels higher that might be more specific to your podcast. And now once you generate these labels, now you could grab that and you might be able to write them back to the metadata of your actual podcast files, so you can use them in some sort of filing system or indexing system. So the interesting thing here, and why Algorithmia is kind of great for these situations, is that you can actually chain these algorithms into each other very easily, because each one of them is abstracted into an API, and you can just call one API into the other, and getting really until you can do this categorization exactly like you wanted to do it.
So what is happening on Algorithmia's servers during each of these calls? So like, for example, I can imagine, on my server, let's say I've got one MP3 I'm going to run, and I kick it to the Algorithmia server for the first thing, which is the speech-to-text algorithm. So I kick the MP3 file, and then it kicks me back a text readout of the audio in the file. And then the next thing in my workflow, I can have the text of that episode sent to Algorithmia servers, and Algorithmia kicks back some combination of I don't know, the TF-IDF algorithm or the labeling algorithm. Explain what's going on in Algorithmia's servers during each of these calls.
Sure. So I guess the first thing I would say is you don't want it to return the intermediate steps to you, because now you'd just be paying for latency on sending stuff up and down from your system too many times. So we actually do have a data API so that you can keep state in between these algorithm calls. So you would essentially, what you would do is you would kind of configure either your script or your application. You would push the first file the first audio file into Algorithmia. We would receive it. We would put it inside our data API. We would send it to the first algorithm. The way that works is, as you hit our API, we send a signal to what we call a worker node to say, hey, this algorithm is required. It's being called by this client, and they're going to be sending you data, and we want you to start processing this. And what happens there is actually we create a container from scratch. We upload, a tarball of the algorithm into that container, route it to a worker node, and our routing is fairly complex because we want it to be as close to you as possible. So think of it as kind of like a CDN. And in that sense, we start processing that algorithm once it's hit the worker. Now, if you sent another file, another MP3 file, and another MP3, so these are different APIs, we would just repeat this process so that you would be running in parallel. So every single one of these calls could be running in parallel. You wouldn't have to do one of your files at a time. So now that we've processed the first, the first file, now we have a text. You would have indicated that text to keep it in memory or to keep it inside the Algorithmia data API. And you'd say, now chain that into the next algorithm, which that process goes again. We would have generated a container. We would have would have sent over the tarball of the algorithm there. We would have loaded it up in memory on the worker, and we would start processing that work. And that's over and over and over again how the system works, which allows you to really do these tasks in parallel at a very, very high volume. So that you have a lot of podcasts, you could do them you would never want to do those serially. It would take you forever.
But if I build this podcast processing algorithm, how much would this cost for each call? How much would the financial cost be?
So in general, the algorithm cost, it actually depends on two things. One is the compute time. So very similar to an AWS Lambda or other serverless, frameworks that you've heard of on public providers, there's a cost per compute second. And that actually depends on the size of the file and what the algorithm is doing. So we have a constant price per second that gets charged anytime one of these things is invoked. The second part of the price is what the algorithm developer has determined that they want to charge as a royalty for their algorithm. And in general, these are very, very low. Very, very low numbers. It's extremely affordable to be able to do this type of computing, especially when you start looking at the time savings that it gives you by just being able to not have to build all the infrastructure around it. So those are the two things that go into price, which is the royalty that the algorithm developer gets and the cost per second on the compute side that we charge.
And just to paint a picture for how cheap these things are, if I pay $1, I can purchase 10,000 Algorithmia credits. So the smallest unit of royalty, I guess, is 1/10,000th of a dollar. How much do these royalties typically cost? For an image processing algorithm, or what about for the best? For the best algorithm, if I've got the best image processing algorithm for some specific thing, is there some sense of monopoly pricing, or do they competitively price even in those instances?
Well, it's a free marketplace, and one of the beauties of a free marketplace is that the prices will get pushed up and down based on the quality of the algorithm and the value that you're getting for it. So, we've seen a lot of algorithms that are zero royalty, right? So this concept of algorithm developers want to make their work available in open source. They are not really interested in charging. They just make it available. And we have a lot of these algorithms where there's a zero royalty cost, and really you're only paying for your second of compute. On the flip side of that, what the pricing ends up being on per call really depends on what the volume is expected of that algorithm. So let's think about an image processing algorithm, like you mentioned. You might be processing 10,000 millions, potentially hundreds of millions of images a month. So in those particular cases, the price per call, the credits is going to be very low, maybe a credit, maybe 2 credits per image, because they know that the volume is going to be so large that you make it up in volume. For more complex tasks, let's say a recognition task on some sort of like prediction or something that takes we've had some security auditing algorithms where you can pass in binaries or websites and you do a security audit. Those can be up to 1,000 credits per call because they know that the volume is going to be a lot lower. It's only going to be run a couple hundred times a day or a couple hundred times a month. And in that case, you're trying to make what the value you're getting is proportional to how many times you're kind of calling it. So that's how the pricing kind of varies in this world of pay per call. And we help developers kind of by showing them examples of other similar algorithms to them to help them with pricing. It's very easy to search for pricing for algorithms on our site and look at the pricing for each one. And then at the end of the day, the market auto-corrects itself. If you have 2 algorithms that do very, very similar things, and one is very expensive and the other one's very cheap, you'll find that people will tend to go to the cheaper one. And there's an opportunity for that developer who has the more expensive one to republish a new version of that algorithm at a lower price.
And my impression is that developers do not have to open source these algorithms. They can choose if they want to open source them.
Correct. So the main principle behind Algorithmia is that algorithm developers control their IP all the way through.
Yeah.
So this is your IP. You're the developer. You've put, sweat and tears behind this. You get to control it. So do you want to open source this? Great. We have all the tools to support you open sourcing it. Do you want to keep it closed source? Great. We have all the tools to do that as well. Do you want to charge for it? Great. We can do that with you as well. If you don't want to charge for it, that's absolutely fine as well. It really comes down to the algorithm developers have control of their work, and they will always have control of their work on top of Algorithmia.
So algorithms on Algorithmia can call each other. How does the price compound? How expensive can algorithms get? Is there anything unexpected about how that would work, or do they just kind of compound naturally? I call an algorithm and I just get price based on that, or maybe you could just explain that.
Yeah, sure. So we have a couple of examples of of things that can kind of compound that way. So let's say you have a URL auditing algorithm, and what I mean by that is maybe what it does is you give it a URL. And then it crawls that entire domain, and then and then for each page, it will analyze what the text on that page is, what the keywords on that page is, and summarize the text there. So you can see how this is kind of like a tree of calls that's going to be built under it. So it's going to be very dependent on the size of that website, right? So it's going to be, if I send this algorithm out on Reddit, that's going to be a pretty expensive call. If I send it on my personal blog, it's going to be really, really cheap. So the way that we do this is that we have a really transparent way of you looking at your account on Algorithmia. So you can run an algorithm, and as soon as you run it, you're going to get an audit of the entire tree of the calls that it made on your account page. So you'll see the entry point, all the algorithms that were called under it, and then how much we charge for each one of those. And in the case of them being for different algorithm developers, the royalties go to the different algorithm developers depending on how theirs were called. So it's a very direct relationship. So it's the same from their perspective. There's no difference between getting called inside of a chain or being called individually. From your side, as the person calling kind of this big chain of algorithms, you get to see exactly the kind of expansion tree and be like, oh, okay, this algorithm actually calls these other 5 algorithms, and this is kind of what the cost goes on running it on this process. So now I understand how long this is going to take, or how much this is going to cost me going from there on.
Have you ever had a situation where somebody creates an infinite loop, an accident maybe, or it just ends up taking all of the money from a customer that makes a call?
We have not done that. We have a lot of stringent controls internally for this. So we statistically analyze these algorithm runs, And anything outside and outliers gets manually inspected by an engineering team. So we'll go back and look at it. And so if there's any situation where something like that happened, like we would go back and reimburse that user immediately. It hasn't happened yet. And it actually would be really hard to do because to be able to get charged, the process has to complete. So we look at the time it took to return a result to you, and we have a timeout of that's built into the system. And so the combination of those two things, allow us to go look at anything that kind of happened that's weird with the system. And we're a very fair company to developers. And so anytime we see anything that shouldn't have happened, we've gone back and reimbursed manually.
Do you think there might be scenarios where somebody would write like some new way to process an image, like the best way to process images for some specific thing, and then since it's so good at that, they also just put in a little code to mine some Bitcoin, and just they have the best image processing algorithm, and it happens to mine some Bitcoin also for them? Like, would there be anything problematic about that?
In general, it would depend on. So like the Bitcoin mining one, kind of the scenario that used to be an interesting scenario. Now it would be like kind of hard to do on anything, given how hard it is to mine Bitcoins in general today. But as I said, what we do is we look at a lot of these algorithms from a statistical perspective on like how long they're running, how much CPU time they take, how much memory they take, and we understand pretty well like what is normal and what is not normal, given the volume and the quantity of algorithms that we've run in the past. And so it's pretty easy for us from that perspective to detect these things. And when we detect these things is when we kind of dive in and manually inspect and say, hey, is this okay? Is this actually something that should be happening? And if we find any foul play, we go and correct it.
So I want to talk about how some software trends have affected Algorithmia and inspired it, perhaps. So you mentioned that whenever a call is made to an Algorithmia algorithm, a container is spun up. Have you been running on containers since the beginning of Algorithmia?
Yes. So we've been, so since the inception of Algorithmia, we've been, containerizing everything. And it's kind of been like, at one time, I'm pretty sure we were probably one of the largest production users of containers, at least in quantity. And now, obviously, large companies have started doing it, and that's no longer true. But we were spinning up and destroying, tens of thousands of containers a day.
Are you using the Amazon ECS service for containers?
No, ECS didn't exist when we started, or at least wasn't publicly available, and neither was Google's. So we actually wrote a homegrown container service that's very specific to how our algorithms work in terms of using the build, using every algorithm as a building block, chaining them together. Like there's very specific routing and resource management needs for our type of system. So we actually have a homebrew system that we've written over the last couple of years.
Fascinating. So when you look at that system versus how Docker has developed, or maybe how CoreOS Rocket, or maybe there's another container technology, these other technologies have the advantage of the network effects and the hive mind of a giant open source community working on them. So how does that compare to working on your own homebrewed container solution?
Sure. So to clarify, we use Docker as our container solution. It's the orchestration part that we wrote internally.
Oh, I see.
So we are heavy users of Docker and have been since the first couple of versions, and will continue to be very heavy users of Docker containers. So
of course. So you were okay, and now I see, because you were contrasting. I said ECS. ECS is kind of like the analog to Kubernetes or Docker Swarm or whatever.
Yeah, and none of these systems at the time when we were building up Algorithmia had the security requirements or the heterogeneous resource management requirements or the routing and scheduling requirements that we had at the time. They were being developed, and a lot of them, potentially would be a solution for us today. And we're always, at the forefront of understanding every single version of these that comes out so that we can consider, hey, should we make that transition over into, as you said, we want to take part of. We not only want to take part of this community, we want to contribute to the community. We've developed some really interesting technology that we would like to contribute back, into the open source because we use it so heavily. And so, we keep ourselves, very aware of all the advancements in not only Docker itself, which is the environment that we work in, but also Kubernetes and the different orchestration services. But, we wouldn't depend on any of the particular cloud providers' services because our platform runs on multiple clouds.
What were the points of inspiration you were looking to when you built that orchestration platform? Because my understanding is that these things are incredibly hard to build and that they take a lot of experience to build properly. Was there some set of experiences you had that gave you enough specialization in container orchestration, or did you have somebody on the team? Or tell me how that orchestration development progressed.
Sure. So, we're very, very lucky that we, from day one, really hired an amazing engineering team. Very, very lucky. And that happened. So, it really was the work between our CTO, Kenny, who's the main architect for the system, and our first couple of hires who actually were very, very early adopters of Docker at their previous jobs. And so really just being aware of how they were talking about, these engineers were talking about Docker, what the future plans, understanding what the future plans for Docker were, we're in Seattle, so, being able to talk to the folks over at Amazon to understand what they're doing, talking to the guys over at Google and understanding what they're doing, allowed us to build a pretty good mental picture of how this needed to work, what were going to be the problems, and how we got there. And then, the second part is trial by fire, right? Like, we went, we built it, we found scale issues, we found routing problems, we found security issues, and just really being dedicated to solve those one by one as we went allowed us to get to the point where we're at today.
Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SE daily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's set it and forget it investment automation. Check out wealthfront.com/SE daily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SE daily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. So when you compare the platform that you've built to Kubernetes and Docker Swarm and ECS, what are the advantages that you see of these different platforms? Since you've been assessing them, do you have so much skin in the game here? I mean, I'm always curious about. I mean, we've had several conversations on the show about these different container orchestration platforms. There's also Mesos. We haven't even mentioned Mesos. How do these different things compare in your eyes? What are the strengths and weaknesses? What are of each platform?
So, for us, it was really about, what was our use case, right? And understanding where they were. So, the first thing, to kind of think about was security. So really proper security in Docker containers didn't just come out until like version 1.8. And before that, it was really, really iffy in terms of how do you lock down a container, what does the network mean for it, et cetera, et cetera. And so that was kind of like a big part of what has driven us is like, how can we guarantee security in not only in the orchestration piece, but also in the actual building of the containers. The second big one for us was routing. So again, like you have to think about like one thing is when you're just scaling an application, right? You're Dockerizing applications or a build system, and you're just kind of distributing it to wherever resources are available. For us, it's, let's go back to the podcast, actual example that we talked about earlier. If we had to build that all into one mega kind of algorithm microservice, right? And you're calling all these different algorithms. We not only need to grab those algorithms and deploy them into available resources, but we also have to put them in the closest place to your data. We also have to probably put them all on the same machine or very close to each other because these algorithms are calling each other. So there is a very specific use case in terms of routing and orchestrating these things together that we needed that was just not available in the, kind of these open source like Mesos, Kubernetes, other orchestration systems. And so it was a lot more about, what our particular use case was, which is pretty unique, right? Like this idea of, modularizing every single algorithm and then still having the system be smart enough to, put all those resources together in one place, that we were just not seeing at the time in the other in other implementations. That said, Kubernetes is definitely getting there, and we've been keeping a pretty close eye on it. My CTO would be able to talk a lot more eloquently about exactly where they are today, but I know that we've been like very closely following them because it's getting there. It's getting the routing, the granularity that was needed for our system is getting there on the Kubernetes platform.
Yeah, so maybe this is also a question for your CTO, but do you think that the long-term view of these orchestration systems is going to be a winner-take-all market, like Kubernetes is going to be the de facto orchestration tool you use, or is it going to be like where Mesos is useful for some applications and Kubernetes is more useful for others? And, because you just described the fact that Algorithmia has a very specific use case that, circumstances were such that these other platforms maybe don't, are not as good a fit for you. But I mean, what do you think is the sector-wide trend?
Sure. So from a more philosophical perspective, I don't think there's such thing as a winner takes all in the software world. We just look back and even, in the more, black and white cases like, Windows versus Linux versus Mac OS, at its core, like it just doesn't happen, right? Like there's always use cases, there might be one that has a much larger market share, but for a period of time. But that just I don't think there's a winner, gets all play here. I do think that, what's going to come up is a lot of these orchestrations are going to be better for one thing or the other. And what we're going to see is in most companies, like with any other software development, different parts of the organization are going to use different frameworks for one reason or another, because it's either the experience that the team has that they've built in that, it's either because they have a general preference. At the end of the day, we as software engineers bring to the table our preferences for certain types of software. And when we go to the workplace and we start deploying it, even if one's particularly better than the other, if I'm just more well-versed in one framework than the other, then I'm going to be more productive in that framework. And so I just in general don't feel like there's ever a winner takes all in the world of software.
I agree with that. And I think that extrapolates to the cloud service provider discussion too, because a lot of people these days, it seems like they'll go with AWS because they have experience in AWS. But these different service providers are building out extremely differentiated services. And obviously, like I think you just said with Algorithmia, you're multi-cloud. I don't know, maybe you want to talk about that some. Maybe you want failover from one cloud platform to another. So there's certainly no winner take all dynamics there.
Sure. So going to the multi-cloud thing, because I think this is a particularly interesting subject that, there's algorithms, data is worthless without algorithms. Algorithms are worthless without data, right? I don't think anybody would argue that. And so one of the big design principles behind the engineering team at Algorithmia was that data is actually really heavy and expensive to move around, but compute is very light and cheap. And so when you're working to build, a company or a service like Algorithmia, where you're going to be getting algorithms that need to process large amounts of data, it is not realistic to assume that the companies, large companies, whatever who've already made a data store bet, either that be Redshift or MySQL in Google Compute or files in Azure or whatever that is, are going to be moving that to the cloud, just to do one task and back, because that's an extremely expensive task to do. On the other side of that, it's very easy for a system like ours to deploy compute to any of these cloud providers and process it directly in the same data center as where your database is or where your data store is. And so what happens is that now that whole concept of like, why would I use, algorithms are something that like need to work fast, and what are you going to do about latency? Well, that discussion kind of goes out the window when you're in the same data center, because, CPUs and hard drives are connected over the network. So if you're in the same data center, your latency is going to be, pretty irrelevant at that point in making these calls. And so that's the general engineering principle behind Algorithmia, is we'll move compute to where your data is.
This brings us to the serverless discussion. You touched on it a little bit earlier. Serverless computing seems like the perfect model for Algorithmia. And for those who don't know, serverless computing is sort of like you can correct me if I'm wrong on this explanation here, but it's the gist of it is, you no longer have to think about servers or containers as a developer. You just think of functions, and you make a function call, and what happens on the back end typically today is some container gets spun up for a transient amount of time, a call is made to the server, and then it spins back down when you're done with it. So maybe you can tell me if you think that definition is accurate, or where you think serverless computing is evolving to, and how it applies to your business use case.
Sure. So I think the explanation is a good one. I think from, and that's exactly it. So let's think about, there's a whole ton of really positive things around this concept of serverless computing, which I think it's funny that's called serverless, because obviously there's tons of servers involved. But, it's like I'm not managing the servers, therefore it's serverless. That's kind of like the layman definition of it. If I don't have to manage it, it's like it's in the cloud.
It's a great gimmick.
Yeah, the cloud is somebody else's server, right? It's somebody else's machine, but that's fine too. And so the general idea here being, yes, I think that definition is good, and there's a bunch of advantages behind it, which is one, I don't have to deal with all the operations of servers, which is an extremely expensive, in a lot of cases when you're operating at scale, something that requires a lot of knowledge and a lot of different knowledge from normal software engineering and software development. It's a very specific kind of knowledge on how to scale these machines and stuff like that. And so you can just extrapolate that entire thing out and say, I don't care, I just want somebody to take care of it. Here's my code, just make it scale for me, make it work when I call it, and that's going to make my life easier because I can concentrate on doing what my specialty is, which is building this application, building this orchestration service, whatever it is. So I think that's the general concept behind serverless. Now that said, Algorithmia is at the core of that. Every call to an algorithm is a serverless computing, it's a paradigm, right? Function. That's exactly what it is. And there's a ton of advantages in terms of that, not only on the operation side of things, but also in cost savings. You would be surprised what the level of utilization of EC2 machines or any machines in the cloud is for applications. And there's obviously examples of companies using, their machines at 80-90% utilization. But realistically, most machines sit there getting paid. You're paying per hour Amazon for a machine that has a 20% utilization 90% of the day. And then at some point it has a huge spike. But because you need to be there, it's not good enough to just scale out when that spike comes, because now you you essentially miss the spike. You're not going to be able to respond to that. And so what ends up happening is that you overpay for resources on a constant basis just to make sure that you can deal with the spikes in traffic or in the spikes of utilization. In the serverless computing world, you're only paying for what you're using. So there's economic advantages of using these type of systems as well, where you're not just sitting on idle machines all the time, which, if you go really, really early days, why does EC2 exist? Well, it was Amazon's idle machines that they were like, well, what do we do with an idle S3 or idle hard drive space? And they're like, so we need this sometimes, but we have a lot of extra of it. Like maybe we can rent it out. I mean, that's how AWS started. And so, you can see how like even, the kings of the cloud, like AWS is this concept came from there, as you're like, and they're saying like, even they had extra space on this capital investment that they made. And like, this was a way of increasing their utilization. And, there's an economic value to that. So I think that's where this world of, serverless computing and where I think the future, obviously, of the cloud is going, which is why am I paying for stuff? We're in the world of the on-demand economy. It applies to computing as well. Like I want things on demand. I only want to pay for them when I'm using them.
So how long till we get to this dream of having a layer of, I did the show recently called about the serverless framework, and kind of the long-term view of the serverless framework is this framework that you could build your application with, and you make calls to the type of function that you want, and it will figure out which cloud provider has the cheapest compute resource at a given time. And this is like the dream. How is this achievable? Are we ever going to have this thing?
Yeah, well, so actually, funny that you mentioned that was exactly how the first version of Algorithmia was intended to work, which is to do arbitrage on computing across multiple cloud providers and just deploy to wherever it was cheapest. What we found at the time was that the price differences between, if you think about Google, I'm just going to consider the three big ones because, for better or for worse, everybody else is kind of irrelevant in this space. You have AWS, Azure, and Google Compute, and their pricing is like.
Sorry to interrupt, but DigitalOcean, not.
So DigitalOcean, I do agree. Like they're big. I just think that they have a disadvantage in terms of the To me, the computing price is driven by electricity. And if you look at what Amazon's doing and what Microsoft is doing and what Google are doing, is that they're buying pieces of land so that they can put data centers next to nuclear power plants, next to dams, so like where the cheapest kilowatt of electricity per hour they can find. So the margin on computing is really driven by the price of electricity and cooling, right? And so they have a natural advantage. DigitalOcean is a great company. We use them. They're very big. I'm just saying, I think there's a natural advantage to these three big players because they have the ability to make the capital investments to be wherever the electricity is cheapest. It's a fun game to do, which is go into Washington State with Google Earth, go look at to where the power plants are and where the dams are, and then look for these really, really large white buildings that surround them. And you take a guess what is inside them. And what it happens to be, it's these guys, right? It's the Microsofts and the Googles and the Amazons of the world who are just building out there, just searching for the cheapest kilowatt of electricity possible. And that's the margin, right? Like that's what they're fighting. And then obviously, they have the layers of services like AWS and all that stuff about. But when it comes down to pure compute, and so when you're looking at them and how they're doing that serverless computing, I think we were looking at doing the arbitrage. They're so similar in price in terms of that the amount of engineering that we were putting into doing kind of the arbitrage part was just not worth it because we found that just we would just pick one, which in our case most of our workload is in AWS. Happens to be that most of our customers are in AWS as well. So going back down to where the data is, put more compute where the data is. We were just seeing that it wasn't worth it to do that full arbitrage. But we actually did have a system that could pull for pricing of the different compute data centers and deploy to wherever the cheapest unit of compute was being done. It just didn't end up playing out to be the most effective engineering wise for our system.
That's a pretty significant pivot you had to make.
This was, kind of like it was very early days. So this was, it was easier to build than you would think. Again, very lucky person and having hired some amazing engineers. I don't take any credit for that part of it.
And you had some experience at an automated trading startup also, right?
Correct.
So how does the construction of a server arbitrage system compare to a, I don't know, options Black-Scholes arbitrage thing or whatever you were doing at the automated trading startup? Sure.
So it actually is a lot closer to what my co-founder and CTO was doing as part of his PhD than what I was doing as part of algorithmic trading. So algorithmic trading is it was at the end of the day was a lot of really nasty VBA code in Excel. Hooked up to Options Express and executing on orders. So it's not, it's looking for differences in prices and stuff like that, and you're executing on a strategy. What Algorithmia was more doing was around smart resource allocation. And so Kenny's, my co-founders, work as part of his PhD at USC in artificial intelligence. Mechanism design really was the design of intelligent marketplaces that did, automatic resource allocation. And so he was actually working for the Department of Transportation at the time and doing resource allocation for transportation units like taxis and buses and stuff like that. And that methodology of looking for pricing differences, but also considering things like, well, the region it's going to be in and like, are you going to be deploying out there and how much time it's going to take? That ended up being a lot more similar to what he was designing as part of his PhD in terms of this smart, intelligent marketplace than what I was doing in algorithmic trading. So this is actually where the inspiration came from, directly from his PhD work.
Fascinating. So, so a few analogs to Algorithmia that I can think of are GitHub and Kaggle. And GitHub is more of a free bazaar of algorithms. And Kaggle is sort of like Algorithmia, but it's more like a machine learning specific marketplace. When you look at these other kind of marketplaces or bazaars, what do you think of? How does that contrast with Algorithmia and the marketplace dynamics at Algorithmia?
Sure. So Algorithmia was born to put state-of-the-art algorithms quicker into production. Right, so we're about production applications, and so this is where like the big difference is going to come out. So GitHub, which we use extensively, by the way, it's about you find great resource for community building, posting, having feedback, posting, your Git repositories, and managing the life cycle of a code repository. But at the end of the day, if you want to get something working from GitHub, you're still responsible for downloading the binaries, figuring out the dependencies, getting your machines working, starting the EC2 servers, or wherever you're putting them, getting that up and running, and deploying an application. So the time between you find a repository that you like and putting that work into production, there's a whole bunch of operations that you need to do as a developer to make that happen. And it could be a short period of time, it could be a long period of time, depending on the complexity, but there's work to be done. So in the case of Algorithmia, you find an algorithm, there's a REST endpoint, you hook it up into your application. If you want to go into production 10 minutes later, you're good to go. Right? So that's one big difference with GitHub. And again, like I don't think we don't see GitHub as a competitor. We see each other as very, very complementary. Sure. And so on the flip side of that, there's Kaggle, which is solving problems in the data science world, the machine learning world, so that you get better results, and really bringing in a community of very, very smart people who get to do, that. But at the end of the day, again, it's not a production system. So what's the result? So you start a Kaggle competition to solve some problem, you get a bunch of participants, and now one of them wins, right? So they get the top, the least error, the most, iterations on it. They get the best result. So now what's the next step? What's the next step for that company who sponsored the work? Well, what usually happens is now Kaggle helps that company hire the top team as consultants to go build that internally. So again, it's not a production environment. It's not about getting things into production. It's about, okay, so you have this problem and we wanted really smart people, so we're going to crowdsource the knowledge of the world to solve this problem that you have. But then once you actually want to, so it can be done is the first proof somebody won it. The next step, you still have to go either put that machine learning model into production, or you need to hire the people who won as consultants, and that's the Kaggle model. So again, it's not about going from zero to working instantly, which is really what where the principle behind Algorithmia is, which is we want to make state-of-the-art algorithms accessible and discoverable by everyone. And so you're a developer, you find something you want to use, you should be able to go to production as quickly as you can get your side of the thing working, because we take care of the rest.
How are the algorithms on Algorithmia compounding on one another? Because obviously, we've talked about the fact that one algorithm can call another one. So you can build and compose different algorithms together. What is your sense of how much these are compounding? Are they compounding on each other, or is it more of a horizontal expansion?
No, they're definitely compounding on each other. So you're getting definitely higher and higher levels. So you start with, we're seeing kind of the birth of these analysis microservices on the platform that have been really interesting. And it's a slow path, but we're definitely starting to see that, which is you start with something, just to give you an example, start with something as basic as this algorithm that I talked to you about, which is called LDA, which is you give it a piece of text and it's going to generate some topic tags. And there's a bunch of different implementations of LDA. It's available in a bunch of different open source libraries. So that's great. So wouldn't it be great to be able to do that? And so now the second part of that is now you see another algorithm or a function that's super basic as well, which is give it a URL and it will clean out all the HTML tags and just return all the text. So let's call it URL to text. And so now imagine another function. This is something, a microservice that already exists on Algorithmia that's called auto tag URL, which is you give it a URL, it sends that URL to text, and now grabs that text and feeds it into LDA, and now it returns tags. So now you have a microservice, which is an own independent algorithm in itself that's calling two other ones, which is doing, okay, you give a URL and I'll return tags. And so we see that compounding effect that's been happening. So similar to what you can do the same thing with the audio one, which is create a podcasting tagging microservice, and that podcasting tagging microservice might do the speech to text algorithm, grab the text, put it through LDA, put it to TF-IDF, return all the results. And so those types of kind of higher level microservices are starting to be built on our platform. And so we are seeing that compounding. That's the beauty of it. Really, that's kind of the big strength of Algorithmia is how easy it is to compound these algorithms. And most importantly, it doesn't matter what language they're written in, right? Because you could have contributed a couple algorithms in Python, I could have done a couple in Java, my friend could have done some in Rust, somebody else could have done some in Ruby, and a completely independent party could come in and be like, oh, I'm going to grab all four of these because they're abstracted on the Algorithmia platform. I can call them all in my language of choice and create a new service based off of it. And that's when you do real contribution, when it's completely independent of language, completely independent of who the people are. You're really getting the best of the best from each corner of the world.
So one thing I'm interested in is the fact that we've talked about these different algorithms where you make a call, you get a simple response, or a very clearly defined response. The inputs and outputs are very clearly defined. But most applications that we deal with on a day-to-day basis have some longer running sense of state. Like if I get in an Uber, I've got this Uber application that is a long-running stateful application for the duration that I'm in the car. So how does this type of, is there a vision for how that type of application could be built and managed using Algorithmia? Or, I've asked this question a couple of times in serverless computing conversations, but how does that fit into the Algorithmia discussion?
Sure. So a couple of things here. One is we have pretty long timeouts. So the life cycle. So while you look at the most serverless computing frameworks, like the most famous one being AWS Lambda, their timeout is 5 minutes. So Algorithmia's timeout is 55 minutes right now, and we're expanding that even more. So we already have the ability of doing like a pretty, and so your Uber example would be well covered in it, because I don't think anybody stays in an Uber for over an hour, just as a general example. And if you are, it's going to be a pretty expensive Uber. And so that's part one. Part two is that we actually have a data API, and that is built into our system, which allows you to store state of the different algorithms. So like as you're computing things, maybe you have like 17 different algorithms computing at the same time, and you're going to do something once all of them are done. So we allow for asynchronous execution of algorithms on one side. And the other one is we have this data API, which allows you to maintain state, even when we might have already spun down the algorithm container and we started a new one. You can store the state in between the different calls. And so the combination of the long timeouts, the data API to maintain state, and the synchronous calls allows you to get to that situation where almost all applications could live in this paradigm.
Well, Diego, I want to respect your time. Thank you so much for coming on the show. This has been a really interesting conversation, and I am a big fan of Algorithmia.
Thank you so much for having me. I love your show as well, so it's been an honor to be on it.